Good evening. Now miscellaneous exercise sum number 7. Without expanding the determinant, show that determinant b plus c, bc, b square, c square, c plus a, ca, c square, a square, a plus b, ab, a square, b square equal to 0. When we are asked to show that value of the determinant is 0 without expanding it, it is clear that we have to show that any two rows or columns are identical. Okay. Start writing. Multiply first row by R1, second by, in fact, multiply first row by A, not by R1. R1 is to be multiplied by A, second row by B, third row by C. Reason? Common sense. Because that gives me ABC here, ABC here, ABC. Now, when you multiply three rows by ABC respectively, value of the determinant remains becomes ABC times, and therefore I have written by AR1, BR2, CR3, and hence dividing the determinant by ABC. Right now. Then next step is what? ABC can be taken common, see the cursor, from second column as well as third column. So after taking ABC common from C2 and C3, see this is original 1 upon ABC. ABC is taken from common from C2, that is why ABC, from C3 also, so again ABC. So what remains is determinant AB plus AC, BC plus AC, AC plus BC, second column 1, 1, 1, third column BC, CA, AB. I will show you this part once again. See, ABC is taken common from AB square, C square. So what remains is BC, here CA, here AB, as simple as that. Now the next step, change C1. C1 changes to what? C1 plus C3. So each element in the first column becomes AB plus BC plus AC. Take that element common. So each element in the first column is 1. Each element in the second column is also 1. Two columns are identical. So value of the determinant equal to 0. Second we already solved. Third sum. Prove that determinant LMN EDF UVW is equal to determinant NFW LEU MDV. We begin with LHS. You will observe that elements in rows are now elements in column. So first step is interchange all the rows and columns. As per property, value of the determinant remains the same, and that is why we can write equal to sign. Is this the required determinant? No. Then interchange second and third rows. You have to show that using this symbol. Or just write R2, 3. So when you interchange second and third rows, you get this determinant. After this step, you have to interchange first and second rows. Then what happens to third? Nothing, as it is. So MDV, you will notice that this is nothing but the required determinant. Just check this NFW, LEU, MDV. Yes. Fourth one, an important one. Show that determinant. Now do not read this as OAB. It is not O. Read this as 0AB minus a 0C minus B minus C 0. Value of the determinant equal to 0. Okay. Yes. Now, first step is, or before that, I have written for this particular determinant, you will notice that Aij is minus Aj. Can you see this? Why? Rather, why means it is given. So I should not ask why. We'll verify this. A13. What is A13? First row, third column, B. Is A13 same as minus A31? Interchange 13. A31 means third row, first column, B. Yes, B is minus of minus B. Okay. Now A22. A22 equal to minus A22. म्हणजे A22 equal to 0. Twice A22 0. So A22 0. Yes. Each diagonal element in fact is 0. Okay. Of course, even if you do not observe this, then also you can solve this. Take minus 1 common from R1, R2, R3. Now you will ask me why, then only we get the answer. Now when you take minus 1 common, you have to write outside the determinant. Why 3 times? Because I have taken minus 1 common not only from R1 but from R2 and R3. I get this determinant. Now interchange all the rows and columns. Basically minus 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 is minus. So first row, which is 0 minus A minus B, becomes first column and so on. Now next step is interesting. Observe the determinant. It is nothing but given determinant. So we have proved that delta equal to minus delta. Can you tell me the number whose positive value is same as negative value? The only real number whose positive value is the same as negative value is nothing but 0. Or you may say shift minus delta to LHS. So 2 delta equal to 0. That is delta equal to 0. Sum number 8. If determinant A11, 1B1, 11C equal to 0, then show that. It would have been better actually had we expanded the determinant initially only. Anyways, we have to prove this. That is to prove. Bring this term to RHS. Find LCM and simplify. So we have to prove what? Just a minute. I'll show you these steps. LCM, cross multiply, and so on. So we have to prove this. ABC minus C minus B minus A plus 2 equal to 0. Now this determinant, how to expand? You know the method. Yes, we get the same. Followed. In exam, it is better to begin with determinant. Determinant is 0. That is, we get this. This is number 1. Then we have to say, we have to prove, that is to prove, that is to prove, and then you have to say which is true from this. Right. I'll wait. Question 9 is for homework. Solve the following linear equations by Cramer's rule. Sum number 10. 1 minute. Okay. Sum number 10. Find the value of k if the following equations are consistent. We solve first one only. Now equations are written in standard form. What do you mean by consistent equations? If the same values of x and y satisfy 3 equations in these 2 unknowns, equations are said to be consistent. Now in that case, this determinant for the condition of consistency is nothing but 0. Now tell me. Now I apply R2 changes to R2 minus R1, R3 changes to R3 minus R1. R1 remains as it is because we are changing R2 and R3. So I get this determinant. You can choose to expand determinant at this stage, or you may further simplify this. C2 changes to C2 minus C1. C3 changes to C3 minus C3, C3 plus C1 rather, because minus sign is there. So you get this determinant. Now just expand this and solve the equation for k. You get k equal to 1 by 3. Sum number 14. An amount of rupees 5,000 is put into 3 investments at the rate of interest of 6%, 7% and 8% per annum respectively. The total annual income is rupees 350. If the combined income from the first two investments is rupees 70 more than the income from the third, find the amount of each investment. So you have to obtain three equations. For that, you have to consider three unknowns. Write down. I'll dictate first part. Let the amount of investments, write down. Let the amount of investments be rupees X, comma, rupees Y and rupees Z respectively. As the rates of interest for these, as the rates of interest on these are 6%, 7% and 8% per annum respectively. 6%, 7% and 8% per annum respectively. Comma, the annual incomes on these, in rupees are 6x upon 100, 7y upon 100 and 8z upon 100 respectively. I hope you are getting this. See, 6% means on 100, 6 rupees. So on x, how many rupees? 6x upon 100. 6% means multiply by 6 by 100. As simple as that. Okay. So these are the incomes. Now next part. As per the given conditions. As per given conditions. Write down three equations. First equation will be what? X plus Y plus Z equal to 5,000. Okay. Now I will not give the numbers now. Okay, what is the second equation? Read the conditions. Total investment, total income is 350. Okay. 6x upon 100. Okay, let it be equation 1. 6x upon 100 plus 7y upon 100 plus 8z upon 100 equal to 350. That is, simplify this, 6x plus 7y plus 8z equal to 35,000. This is second equation. And which is the last condition? Combined income from first two is rupees 70 more than income from the third. combined income from first two. So 6x upon 100 plus 7y upon 100 is 60 more than third. So equal to 8z upon 100 plus 60. See, you have to use common sense. That is why, in fact, it is difficult. 6x plus 7y minus 8z equal to by 60 or 70. What is given? 70 more. I'm sorry. They say it is not 60. It is more by rupees 70. So 7,000. Now we are supposed to solve this using Kramer's rule. Now sum number 14. I think I have read this sum. Let the, okay, we have to start from this, I think. So what are the three equations as per given conditions? This is also over, I think. So as per given conditions, these are the three equations. Okay. Now, what is D? Determinant of coefficients of x, y, and z. Okay. So this is D minus 16. dx comes out to be. Now when you expand, please take 1000 common. Otherwise also you'll get the answer, but it is better if we take 1000 common. So dx comes out to be, see the calculations, minus 28,000. D minus 16. So dx, dy, dz should be negative only because amounts of investment cannot be negative. dy comes out to be minus 24,000. And dz comes out to be minus 28,000. So by Kramer's rule, what is x? dx upon d, that is 1750. What is y? dy upon d, that is 1500. Z, dz upon d, that is 1750. So you have to write the answer as rupees 1750, rupees 1500, and rupees 1750 are to be invested in three investments respectively. 15th one, show that lines x minus y equal to 6, 4x minus 3y equal to 20, and 6x plus 5y plus 8 equal to 0 are concurrent. Also find the point of concurrence. As point of concurrence is also asked, I solved first two and I showed that the same values satisfy third equation. But of course in exam, they will expect you to use determinant. So show that equations are solvable, that is determinant of coefficients is non-zero, and then that value of the determinant for condition of consistency equal to 0. Here I have solved first and second equations. Third equation is written as 6x plus 5y equal to minus 8. Okay. Solve first two to get x equal to 2, y equal to minus 4. If equations are consistent, these values will satisfy. If they are not, values won't satisfy. So put these in 3. LHS comes out to be minus 8, same as RHS. So what is the conclusion? Equations are consistent, so lines are concurrent. What is the point of concurrency? Oh, the word is concurrence. Okay, the point of concurrence. Or as I said, show that determinant 1 minus 1, 6, 4 minus 3, 20. 6, 5 minus 8 equal to 0. But if you use this method, then again we'll have to solve any two equations, right? So that's it for today.